Our study is a joint operation of Utrecht University and Wageningen University in the Netherlands. Vet-Vice cow signals is also involved, and also our Boehringer Ingelheim and the NEDAP company which provided the sensors. So our study, Sense of Sensors in Transition Management, is a multi-annual study. It has incorporated 17 dairy farms spread through the Netherlands. And the focus of this study eventually is a successful transition for every cow. We use two types of sensors. We use the NEDAP SmartTech neck and the NEDAP SmartTech leg sensors. The neck registrates the eating time, number of eating bouts and duration per eating bout, rumination time, number of bouts and duration per bout. The non-chewing time, which is actually 24 hours per day minus eating time minus rumination time. And it also has heat detection. The leg sensor registrates the lying time, number of bouts, duration per bout, number of steps, also heat detection, and standing time. The goal of this specific study was to relate the eating time in the transition period, which is actually a more extended transition period, starting from 6 weeks before parturition until 4 weeks after parturition, and to relate that eating time to the interval between calving and first service. So 17 commercial dairy farms in the Netherlands, over 2,000 dairy cows, and we split them up in multiparous cows and primiparous cows. I'll explain later in my next sheet. The data collection took more or less 2 years, was in 2015 and 2016. So as I said, we recorded the eating time in an extended transition period and related that to the interval between calving and first service. Statistical method we used was a Cox proportional hazard model. And in this model we used farm parity mean eating time per week. So from 6 weeks before until 4 weeks after calving you've got 10 weeks. And we also used the standard deviation of the eating time per week. And that was according to Scheffer from 2009, published in Nature, to use the SD as an explanatory variable before the changes in the mean happen. So all farms were free stalls with slatted floors. Around about 50% had pasture access, 50% used an automatic milking system, and so 50% used a conventional milking system. 50% of those farms had deep litter cubicles, and so has 50% has mattresses. All these 17 farms belong to the top 25 producing farms in the Netherlands. So just so you know that what we're talking about. First of all, these results. And this is also, according to the paper from Dr. Neves, there are lots of differences in behavioral aspects. Now here's only the eating time, but it's the same for rumination time, lying time, number of steps. There are lots of differences of displaying several types of behavior between primiparous and multiparous cows. So that's why we split them up in this study. So you can see that before calving, during the 6 weeks before calving, there is, well, let's say over half an hour, almost an hour on average, difference in eating time between primiparous and multiparous cows. So primiparous cows will eat longer per day, up to an hour, than the multiparous cows. Just to make it clear, before calving, looking at the primiparous cows, the primiparous cows are actually primiparous cows after that peak. Talking about that peak, the sensor, which is attached to the neck collar of the animal, is just like your telephone knowing I have it in an upright position or have it in a broad position, and your telephone knows when to switch because you want to watch a video or something. It has more or less the same way of working in that sensor. and it registrates its position in space. So it has a three-way axis, and in the three-way axis it uses also a accelerometer, so it knows when it's moving and in what direction it's moving. And on the basis of that, NIDA created an algorithm. But when we created this figure, we thought, what's happening at the day of calving? There is a big peak in eating time for the multiparous cows, a lot smaller peak for the primiparous cows. So what happened, what we've done is we called one of our farmers, which was closest to our university, and asked him to call me when a cow was calving so we could see what was happening. And when you're at the farm, then suddenly it's quite obvious, because what happens straight after a cow, especially a multiparous cow, has calved, she starts to lick the calf. And that's the same movement as eating, right? So that peak consists for, well, most of the peak consists out of licking the calf. And already you can see a difference in that licking of the calf between primiparous and multiparous cows. Maybe because of difference in behavioral aspects, maybe because farmers tend to be more careful when heifers will calve for the first time than when older calves will calve. So after parturition, you can see that the dip is more or less the same. But after that dip, they start to separate again. And then the primiparous cows will spend more time eating than the multiparous cows. Which doesn't mean that they have a higher dry matter intake. So that's something you need to take into account. So as I said, we try to relate this eating time in these 10 weeks to the interval between calving and first service. And despite the farmer's decision to artificially inseminate a cow or a heifer, farm did not stay in the final model. What did stay in the final model was the eating time in weeks -5, -3, and +1 for primiparous and multiparous cows, and the standard deviation of the eating time week 1 and week 2 after calving for primiparous and multiparous cows. And in this model, we used interactions for the behavior for primiparous and multiparous cows. Significant results were the week -3 for the primiparous cows, week +1 for multiparous cows, and the standard deviation in week 1 and week 2 of the eating time of both primiparous and multiparous cows. So if you look at the Kaplan-Meier, the left one are all the 17 farms. So what does it say? It happens before day 100, grossly, with a means of event around day 84. At the right, you can see that there's a Kaplan-Meier for primiparous and multiparous cows, and there's not that much of difference. You can see that the lower one stops much sooner than the upper one, and that's probably because farmers tend to give multiparous cows in the Netherlands a bit more chance to become pregnant again than the primiparous cows. So looking at these hazard ratios, I could talk a lot about these hazard ratios, but I think to make it more practical, it's not about the exact ratio, because we have lots of animals. We remove the duplicates, but we have lots of animals. And the thing is, there is a relation between the eating time in this extended period and something that happens weeks after the period we measured the eating time. And of course, that's quite an indirect study, and it's an indirect relation because there's lots of things are happening in the time in between. For instance, we removed, we censored 241 cows in this data set because they were culled, but they were not culled immediately after calving. They were culled well, sometimes day 100, day 150, day 100, 180, after calving, but they weren't inseminated anymore. So we censored those animals in the final data set. So if you look at what's happening in these couple of weeks, then you can see that for primiparous cows before parturition, there's a relation with the eating time and the interval between calving and first service. But after calving, the first 2 weeks are for both primiparous and multiparous cows equally important. But there's a difference of the standard deviation in week 1 and related to the standard deviation in week 2. And that's quite interesting because if you have an increase of the standard deviation with a factor 1, she will be inseminated later. If the standard deviation in week 2 increases with a factor of 1, the insemination will be earlier. So, question is why? We don't know yet, but we're trying to figure it out. The thing is, we also studied the relation between the eating time before calving and the eating time after calving, the means and the standard deviation. What happens is, according again to Scheffer 2009 in his paper in Nature, that sometimes the mean isn't that different, but in some cows there's huge variance in standard deviation. And especially those cows, if they tend to fluctuate more before calving, they tend to fluctuate more in eating time after calving. So we're trying to figure out what's going on in those cows. Why do they have this fluctuation in their eating time? And how is it related in these data sets to reproductive indicators? We also studied the number of inseminations and the expected calving interval. It's a common used factor in the Netherlands, which is actually the number of days open plus 280. But they were not that reliable, so we kicked it out. As I stated already, there's an indirect effect of this eating time in this entire period of 10 weeks around parturition. And what happens weeks later when you want to serve your cows again, to get them pregnant again. And we are going to relate this to calcium concentrations, BABH concentrations, other postpartum diseases, and we all tend to fit that in a model to relate that to reproduction parameters. So it states come see our posters. They were here the day before yesterday, so I hope you have seen our posters, where we try to explain the relation of several behavioral parameters that are already related before parturition to the calcium concentration we took within 48 hours after calving. And there's also a big correlation of the calcium concentration and the BABH concentration. I want to thank you for your attention. I want to thank Boehringer Ingelheim and NADAP for sponsoring me to be here. And last 2018 we were in Sapporo. And in 2 years we'll go to Madrid. Hope to see you all over there. Then we go to Cancun, and then I hope we can see you all in 2024, where we will place a bid to organize it in the Netherlands. Thank you very much.